Good day, everyone. I am Brendale M. Suses, and I will discuss the improvement of composite sections subjected to negative movement, particularly the process of concrete pouring. So, since there are three different modes of how to improve composite section, I will be only focused on the concrete pouring sequence. So, the other two methods will be discussed by the next reporter. So, let us start by defining some key terms in this report. So these are the key terms. We have the positive bending, negative bending, preloading, and pre-stressing. So these terms are commonly used in my report. So let us know about them. So first, positive bending. It is a bending movement that produces tension on bottom side of a beam and compression on the top side of the beam. So basically, positive bending is the most common type of bending that we have to encounter when designing a beam. So if we can remember in the structural uh, or in the reinforced concrete design. So we commonly design beams which are subjected to compression on the top side of the beam and on the bottom side the tension part. So I hope we all remember that one. And the next term is the negative bending. It is a bending moment that produces compression on bottom side of a beam and tension on the top side. So it is the complete opposite of the positive bending. So here we are dealing with the compression on the bottom side of the beam and the tension on the top side of it. So we often or we encounter this few times in the reinforced concrete design wherein uh, I have noticed that the negative bending occurs in the reaction or in the support of the structure. So in the support, the beam at the support part is subjected to compression on the bottom side and tension on the top side. So that produces negative bending. So next is the preloading. So preloading is the amount of force exerted against the rolling elements without any application of any external forces. So basically, preloading doesn't include uh, the uh, the external forces the the example for the bridge. It doesn't include the loads or the forces coming from the cars, from the people walking on the bridge. So preloading, the engineers or the construction only apply loads prior to the uh, application uh, or prior to the external forces that will be applied on the bridge later on after the construction is done. So next is the pre-stressing. So pre-stressing is the introduction of compressive force to the concrete to counteract the stresses that will result from the applied loads. So basically, this compressive force or the pre-stressing, uh, this will be coming from the preloading that is applied. So that would be for the key terms. The next one is the location of the bending regions. So as discussed earlier, we have two types of bending. The Actually there are three. So we have first the positive bending, negative bending, and lastly the zero bending. But we are not dealing with zero bending here. So now let us uh, know what region belongs to negative and belongs to positive bending. So let me have this laser on. So negative bending, as I have talked earlier, occurs in the support part. So here we can see here the moment here, or the bending here, is negative. Also here the negative, negative, and negative. So negative bending, the direction of the moment is counterclockwise. Meanwhile, the positive bending, the direction of the moment is on the clockwise. So if I draw this one, also, by the way, also the positive bending refers to the sagging, and wherein we can see deflections on the downward side of the curve, and the negative bending, on the other hand, it is hugging, or the curve is upward, in an upward direction. So if we draw that one, so since we have here support, so it will create negative bending. And since this part here is subjected to preloads, or the loading, so it will probably sag, so creating a positive bending. So same goes here, here, and here. So this part, this part here is the negative bending, the positive bending, negative bending, positive bending, negative bending, positive bending, and negative bending. I know this is very familiar to us from the start of the uh, what subject is that, the uh, strength of materials. Strength of materials, we are dealing with uh, these particular moments, especially in the shear moment diagrams. So the next one is the uh, way of how to improve the concrete, the compression in concrete. So first is the concrete pouring sequence, or the concrete pouring. So we have here three steps. So let's start with the step one. The step one is the concrete casting and preloading in positive bending moment region. So this is moment typographical error. So the concrete was first poured, and addition temporary loads are also applied in the positive bending region. Thus, pre-stress will be produced in negative bending moment region. So we already know about these terms. So this means that the the first the first process is to pour the concrete. So here are the concretes, this dark portions here, and the next one is the application of the preloads. Here the preloads, the arrow, uniformly distributed loads pointing downward. So that particular preloads will create a pre-stress on the concrete. This is to analyze the performance of the structure. So the next step is the concrete casting in negative moment region. So thereafter, after the first step, the concrete is poured in negative bending moment, and the temporary loads will not be removed before the hardening of the concrete in the negative bending region. So said here, the preloads will not be removed from the structure uh, before the hardening of the concrete. So that will create a, negative, that will create a pre-stress here in our concrete. So next is the removal of preloading. So we can see here in the figure that there are no uh, uniform distributed loads already that is applied on the step 1 and step 2. So Here, after removal of additional temporary loads, the concrete in hugging bending region will be under compression. So concrete in hugging bending moment. So hugging bending moment, that is the negative bending moment. So here, in these regions here and here, this will now be under compression. So the initial compressive stress from the pre-stress in concrete will be used for reducing the concrete in the service stage. So that is how concrete pouring sequence work. So that will conclude my report. The next two modes of improving the performance of the bridge structure will be discussed later on. Thank you and stay safe, everyone.